Hello, happy summer. I'm Victoria weather meteorologist Ryan Henning with another video. We're not going to do a forecast today. I just thought I'd go through some of the dynamics involved with the current pattern. I hope you're doing well. Obviously, well, maybe not obviously for everybody, but June 4th, we're into June now. June 1st is the beginning of what's called meteorological summer because there's so many complex fluid dynamics involved with the weather that it's nice just to divide up the calendar into months rather than find the apex of the sun's descent over the Tropic of Capricorn or what have you. So June through August, I think what a lot of people would define as summer, especially school kids. That's what meteorological summer is. So we are in summer. So congratulations if this is your favorite season. It's mine. So I'm very happy to be here. And the weather pattern is kind of turning into something that's a little more reflective of what summer really looks like on a weather map. So I thought I'd talk about a few of the things that we're looking at today, and we'll probably be able to expect for the next 3 months. The first thing I thought I'd point out is that in the summer there's usually a loft, at the upper levels, not a lot of action going on. So the jet stream that we talk about, big jet troughs, big jet ridges that we talk about in the summer, they're a lot less apparent, and they don't really, they do just as much, don't get me wrong, but they don't show up as vividly on the analyses because they're only in the winter. They can have winds through them up to 200 miles an hour, whereas in the summer it's a pretty good sized jet if you've got a wind of 90 miles an hour through it. So they're significantly weaker, but just because of all the energy with the heat at the surface, they can still make themselves pretty well known. But they don't show up as much because you don't have the clashing of air masses. Like in the winter, the Caribbean it's a tropical sea, and that feeds the Gulf of Mexico, and the Gulf of Mexico stays very warm as well. So the southeastern United States is always very cold, very warm, excuse me. Even when they think it's cool, it's still, it's newsworthy if it gets down to the 30s. So that they stay very warm, whereas the Canadian Arctic, when it doesn't have the sun, it can get very cold. So you're always going to have a much more significant clash of air masses, and that can dip further south to the northern plains, central plains, etc. So the clash of air mass and the strong temperature gradient through an entire air mass, and so we're talking about at sea level. So obviously in the Rockies it's always going to be a bit colder because you're higher at elevation, there's less air up there, so you're not going to see like a jet just following the Rockies because the Rockies are there. But you get the stronger clash in air mass in the winter, and so the sharp temperature gradient, it informs of where the jet is. It's called thermal wind, and it feeds the jet. It's a complex math equation that I won't get into now, but just know when you look at a weather map, if you see a sharp cold front, probably about half a mile up or so, half a mile or more, there's a jet stream or a jet streak overhead. So without the sharp temperature gradient, because now if you get a cold front going through, say, the Dakotas or something into Nebraska and Iowa, south of it you might be 90 degrees, and north of it it's going to be about 75, whereas in the winter it could drop from 40 to negative 10. So it's only like a 15 degree temperature gradient versus up to a 50 degree temperature gradient in the winter. So that is why the jet streaks that I was mentioning don't really show up. The other thing about a strong jet stream is that when you get troughs and ridges, it forms a wave, and waves tend to progress west to east. So the sharper the wave, the shorter wave features, They move faster, broader waves move slower, and without a strong jet stream, you get less progression. So that's kind of what we've got going on in the plains this week. I posted yesterday about how the pattern seems to be stuck. I looked at the Storm Prediction Center and their thunderstorm outlets, and that's why, because there's no flow aloft and nothing to help usher things along. There's a surface-based feature called a lee trough, which is caused by winds moving over the Rockies and then descending rapidly, and that leads to some surface areas of low pressure. It doesn't change the air mass, but it stirs things up enough that it produces the thunderstorms in the plains. And it's great for storm chasers and farmers out there because it produces those strong thunderstorms that chasers like to look for. But it also brings rain to, the bread belt, or the, what do they call it out there? Maybe the wheat belt or something like that. I don't know, the high plains, where, western Kansas is rife with wheat farms. So that's what's going on. It's not an upper level feature that's producing the severe weather in western Nebraska, eastern Colorado, that part of the world. It's also not moving because the upper level pattern isn't progressive right now because there's not much of a pattern to speak of. So that's also it's telling why it's drier in the summer as well, because they're usually, in order to get thunderstorm activity, you need some sort of trigger mechanism, which is the introduction of lift. And one of the best things at introducing lift is cold air, because cold air sinks, and then if you've got warm air, say in the upper Midwest, which is more active in the summer, and it's just completely stable, well, not completely, but mostly stable in the southern plains because it's too hot and the cooler air doesn't reach that far south. But it's more stable in the summer because there is less cool air to work with. And cold air is denser, so it stinks, and it forces warm, moist air up, which produces showers and thunderstorms. And this, of course, works in any precip situation. So snow is caused by lift, just stratiform rain, lift, hail, updrafts. So that's why it tends to be drier, where it's really hot in the southern plains in the summer. And that, again, goes back to the fact that there's no clash of air mass, so you don't have any jet structure, pattern stable, high pressure, no rain in the southern plains. But you might be saying, Ryan, I live in Atlanta and it storms pretty much every day here. Why is that if you just said that the hot air leads to fewer thunderstorms? Well, that's because it's also humid. In Oklahoma City, for example, it's not terribly humid in the summer, whereas in Atlanta or Birmingham or Miami or Orlando or wherever, it's very humid. And the thing about moisture, even though it makes the air feel heavy on your skin, molecularly, it's actually lighter than air. If you look at the molecular structure of water, H2O, O, if you remember your periodic table, has an atomic weight of 8, and the hydrogen is 1, so that's a weight of 10. Most of our atmosphere around us, even though we breathe oxygen, which is O2, by the way, and I'll just say that, it's 8 plus 8, so 16. So 16 heavier than the 10 of water. Or it's CO2, which, if I remember correctly, carbon is 6, so that's 24. So no matter what particles you're looking at, water is lighter than air. It sounds weird to say, but molecularly speaking, so if you get water vapor, which is basically what humidity is, it's making the air lighter, which means it's more buoyant. So any trigger, say a sea breeze or just a wave coming off the mountains in the Smokies, they're gonna trigger some thunderstorms. And that's what you get a lot in the southern U.S. along the Gulf Coast. You get or Florida especially. If you get a moist breeze moving into a less moist surface, like over a landmass. The drier air, what I'm trying to say is the drier air is going to be more dense. So the oceanic air, which is warmer and more moist, is going to lift, and that's a sea breeze thunderstorm. Otherwise, there's also something called free convection, which you're boiling the air mass, or not actually boiling it, but that's the same kind of concept. You're heating it from the surface, and if you warm it enough, it's just going to lift. And you only reach that point if the air isn't too dense, such as with a saturated air mass like you're going to find in Atlanta or the southeastern United States. So I hope that helped you out with understanding some of the summertime dynamics that we're going to be experiencing. We're starting to see already, and we will be seeing for the next few months. And hopefully it's just air mass thunderstorms that we're going to worry about, and don't have to worry about anything more complicated like a hurricane or anything like that. Enjoy your summer. Happy June. I'm Victoria Weather Meteorologist Ryan Henning.